Hello students, this is a video on the QA topic test available on the Bodhee Prep Android app. Now, these tests, the objective is that once you've done the basic concept of a topic, you'd want to see whether you're able to apply those concepts in a test or an exam format or not. So that is when you take these topic tests for each topic. With every test, there is a video which gives you the solutions and a brief analysis of how the paper is in terms of level of difficulty and time. There are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description below. So make sure you download the app and make the most use of these tests. This video is on the topic circles. This is the test number 5 on the topic. Overall, a moderate sort of a test where getting 6 to 7 questions correct would give you a high percentile of 95 plus, and the attempt time should be somewhere around 20 to 22 minutes, in which you'll be able to go through the questions, find your 6 to 7 questions, and get the required percentile. If you look at the question, the first one says AB is the diameter of a circle of radius 5, P and Q be 2 points on the circle so that length of PB is 6, AP is twice of AQ. What is the length of QB? So we draw a circle and the diameter, the circle, diameter AB. The length of AB will be 10. Also length of PB. Suppose P is a point somewhere here is 6. This is AB. This will have length 10. We have AP with length 6. So first thing we do is we have PB with length 6. So we join AP. Using the Pythagoras theorem in the triangle APB, because angle APB will be 90, angle in a semicircle, we can say AP square is equal to PB square. Sorry, AP square plus PB square is equal to AB square. AB is the hypotenuse, so AP square plus 6 square is equal to 10 square. With 6 and 10, we know that the Pythagorean triplet will be 8. So the length of AP comes out to 8. Next, AP is twice of AQ. So AQ will be half of AP because AP is equal to 2 times AQ. So AQ is equal to AP by 2, which is 8 by 2 or 4. If we draw AQ somewhere here, say AQ is 4, we have to find QB. Again, in triangle AQB, since angle Q is in a semicircle, it will be 90 degree. So in triangle AQB, we can have the Pythagoras theorem and we can say AQ square plus QB square will be equal to AB square. AQ is 4, QB is to be found out, AB is 10. Therefore, QB square is nothing but 10 square, 100 minus 4 square, 16 or 84. Therefore, QB will be root of 84. Root of 81 is 9. Therefore, this will be just more than 9 from the options nearest to 9.1 becomes my answer. I'd say easy to moderate question, not more than 2 minutes to solve. Just make the two right angles and apply Pythagoras theorem. In the given figure, ABCD is a cyclic quadrilateral whose side AB is the diameter. O would be the center. ABC, diameter of the circle which passes through AB and C. ADC is 130, find CAB. Since ABCD is a cyclic quadrilateral, angle D plus angle B should be equal to 180 degree. This angle D here, ADC is 30, CBA will be 50. 180 minus 130. Also, angle C here will be 90 degree because it is an angle in a semicircle. Therefore, if you look at CAB in triangle CAB, the sum of these three angles should be 180 degree, and therefore angle CAB will be nothing but 180 minus 90 minus 50, which will give us the answer as 40 degree. Option A. So this is an easy question, basic application of two properties, and we get the answer. Not more than a minute and a half to solve. Two equal circles with centers O and O dash cut each other at two distinct points C and C dash. neither O nor O dash falls within the intersection. So the centers lie outside the intersection of the circles. Smallest range that includes all possible values of C, O, C dash, C dash, O dash, and C. Suppose the sum of these two angles is A. Now the first extreme is when the two circles just touch each other. At this point, these two will not be distinct points, they will be the same point, C or C dash. And we have the centers at O and O dash. Now, if you look at the value C O C dash, it will be 0. C O dash C dash will also be 0. So the sum here is 0. But we're not looking at this point because there have to be two distinct points. So the moment we bring the circles a little closer, we will have two distinct points and this angle here will increase. And therefore, for us, A has to be greater than 0 becomes my first uh, limitation or first extreme. The other extreme would be when the circles are so placed that the centers of the circle lie on each other's circumference. That is, O lies on the circumference of circle 2, O dash lies on the circumference of circle 1. This is C, C dash, two distinct points, O, O dash. Now, this is the extreme point because the centers did not lie in the intersection. And therefore, we're looking at a position just before this. But at this point, if you look at it, OC, CO dash, and OO dash, all of these three are radiuses or radii. Therefore, this will be an equilateral triangle. This angle is 60. Similarly, here this angle is 60 because OC dash, O dash, C dash, and OO dash are radii of the circles. So equilateral triangle, and therefore angle COC dash is 60 plus 60, 120. Similarly, angle CO dash C dash is also 120, and therefore their sum will be 240. But we have to stop just before that, and therefore A has to be less than 240. This was the sum which we are calling it. Therefore, the values of A have to lie between 0 and 240. Again, we would have done questions like this earlier, and therefore I'm saying at best a medium level of difficulty question, 2.5 minutes should be good enough for this question. In the adjoining figure, 1 and 2 are circles with circles with P and Q respectively as centers. The two circles touch each other and have common tangent that touches them at point R and S. The common tangent meets the line joining P and Q at O. The diameters of 1 and 2 are in the ratio 4:3. So if we join PR, that will be the diameter for the circle 1. SQ will be the radius for circle 2. Since diameters are in the ratio 4:3, we can say that the radii will also be in the ratio 4:3 because radius is half the diameter. And therefore, we can say the radius here will be 4x, the radius here will be 3x. It is known that PO is 28. What is SO? SO. This will be 90 degree, this will be 90 degree. Radius and tangent intersection points. Now, triangle OSQ is similar to triangle ORP. Angle O is common, S and R are 90 degrees. Therefore, SQ ratio of sides, SQ upon SQ, SQ, SQ radius upon RP will be OQ upon OP. SQ upon RP is 3/4, ratio of the radii. OQ we do not know. Again, OQ we do not know. OP is given as 28 or PO is 28. 4 7, so therefore OQ comes out to 21. Which means PQ is equal to 7. Also, PQ is nothing but the sum of the radius this and this. Therefore, 4x plus 3x is 7. And therefore, x is equal to 1. Therefore, these two radii are 3 and 4 respectively. Now, we have to find the length of SO. In triangle SQO, angle S is 90 degrees, therefore OS square plus SQ square will be equal to OQ square. SO is to be found out. So OS square is equal to OQ square. 21 square minus SQ. 3 square. 21 is 441 minus 9. Therefore, OS square is equal to root of 432. 432, 4789 divided by 3 is 144. Therefore, this becomes OS is equal to 12 root 3. 144 into 3 is 432. So, the length of OS comes out to 12 root 3, our answer. Again, moderate level of difficulty. Looking at similar triangles, about 2 to 2.5 minutes to solve. The next question continued says, on similar lines, what is the ratio of PQ to OQ? So I'm using what we did in the previous question for this as well. What is the ratio of PQ to OQ? This we've already calculated actually. OQ we had calculated as 21, PQ was 7. Therefore, PQ upon QO will be 7 is upon 21 or 1 by 3. From the previous calculation, option B becomes the answer. Even standalone, I don't think this question will take more than maybe a minute, minute and a half, because he's just looking at the triangles, similar triangles, and finding out the ratio. Two circles of radius 4 touch externally. Each of these two circles is touched externally by a third circle. If these three circles have a common tangent, then the radius of the third circle. We draw one circle, we draw another circle. Okay. This is the second circle, each of them 4 centimeters. Since we need a common tangent and a third circle as well, let us first draw the common tangent. And then we draw the third circle touching all of them. That circle will be somewhere here. Two circles of radius 4. I am joining the centers. This is 4, this is 4, this is 4. Suppose the radius of the circle is R. R. They have touched. What is the radius of third circle? From this line, from this point, drop a perpendicular. So what you're doing is you're drawing a straight line here. Now this straight line will be tangent to the two circles of the same radius, because we're drawing a perpendicular. Therefore, if we look at this triangle, so this is B, this point is C, this point is A. The center of the smaller circle, center of one circle, and the intersection point of the two circles. Here we can say, since this will be 90 degree, AB square is equal to BC square plus AC square. AB is the radius of the will be the sum of the radius of these two, so 4 plus R whole square. If you look at BC, BC is 4 square. If you look at AC, AC is this line minus this R. This line will be the circle of the largest radius of the larger circle. Therefore, AC will be 4 minus R. We get a equation in R which we can solve to get the answer. 16 plus R square plus 8R is equal to 16 plus 16 plus R square minus 8R. R square cancel, 16 cancel. Therefore, 16R is equal to 16. R is equal to 1. Option D becomes my answer. I think medium level of difficulty. The problem here would be drawing the figure and then finding out the length for the triangle. So maybe 2.5 to 3 minutes to solve. In the given figure below, AB is the diameter of the larger circle with 3 smaller circles drawn inside the circle such that their diameter are along AB. The radius of these circles is 1. 1, 1, 1, 1, 1 and 1, and therefore the diameter of the larger one is 6. Length of AB is 6. Another circle with center R is drawn, which touches the two smaller circles and the larger circle. What is the length of the radius R of the circle? All we have to do is shift this circle here, and therefore they will be identical circles. But another way of looking at it would be from O, join R, and then take the line forward. This line will pass from the point of contact. Line joining the centers passes from the point of contact. All you have to draw is a common tangent, and therefore this will be a straight line. Now this, suppose the point of contact here is C and the point of contact here is D. OD will be nothing but OC plus CR plus RD. Suppose the center at R. OD is the radius of the larger circle, which is 3. OC is the radius of the smaller circle, which is 1. CR and RD are the radiuses of the circle that we have to find out, so R plus R. So from here we'll get 2 is equal to 2R, or R is equal to, option C becomes my answer. It's an easy to moderate sort of a question. Just have to spot that straight line. Once you do that, the question becomes a simple equation. Therefore, about 2 minutes to solve. A tailor cuts two equal semicircle pieces from a rectangular cloth of 40 by 80. A rectangular cloth of 40 by 80. Sorry. Something like this. Now, from here, two semicircles are to be cut. This length here is 80. This length is 40. The minimum possible area of the cloth left. So we have to cut the semicircle with maximum area. So instead of placing them around the side here, we will place them on the base and the top of the rectangle. Would look something like this, just touching each other. Centers here, the circles are equal in size, therefore the radius of one is R, the other is R as well. What we do is we join these lines. I'm joining the centers of the two circles and dropping a perpendicular from the radius of the first, center of the first to the base. Suppose we get a triangle ABC. Clearly, AB is equal to 40 because AB will be equal to this side. AC is equal to, if the radius of the circle is R, R plus R, that is 2R. And if you look at CB, this length is R, radius of the circle. This length, and therefore this length is R as well. So CB will be nothing but 80 minus 2R. Now in triangle ACB, we put the Pythagoras theorem. AC square is equal to AB square plus BC square. So AC 40 square is equal to AB. AC was 2R. 2R whole square is equal to 40 square plus BC or CB. 80 minus 2R whole square. 4R square is equal to 1600. 4R square is equal to 1600 plus 80 square. 6400 plus 4R square minus 8 to the 16 to the 30 minus 320R. 4R square cancel. 320R comes out to 8000. R is equal to 8000 upon 320. 0 cancel. 800 by 4, which is 25. So the radius of the circle comes out to 25, and therefore minimum possible area of the cloth left will be the area of the cloth. Rectangle will be 80 into 40. From there, subtract the two semicircles. So twice into half pi R square. This will become 3200 minus half and half cancel. 25 square is 625, 625 pi. Option B becomes my answer. Moderate to maybe difficult level as well, because again drawing the figure is a challenge. About 2.5 minutes to solve. In the given figure, two circles with radius are intersect at each at points M and N. PMQ is 90. What is the area of the region common to both the circles? What we do is we join PN, we join QN, we join PQ as well. First of all, since this is 90, these two angles will be 45 and 45. Since the sides are equal, so the opposite angles will also be equal. Also, PM is equal to PN, MQ is equal to QN, and PQ is common. Therefore, triangle PMQ will be congruent to triangle PNQ. Hence, the opposite angle, this will be 90, these will be 45 and 45. And therefore, this angle, entire angle will also be 90 degree. Now, we join MN next. We have to find the area of the common region. So, we find out the area of this segment and then double it. So, the area of the required segment will simply be area of sector PMQ, PMN minus area of triangle PMN. Sector PMN will be 90 by 360 because angle P is 90 into pi r squared. Triangle PMN will be half of PM into PN because again angle P is 90. This is 1 by 4 pi r squared minus half of r into r, which is half of r squared. This is one segment. The required area will be the double segment. Therefore, common area will be double of this. Common area comes out to twice into 1 by 4 pi r square minus half r square. So this is r square common. Pi by 4 into 2 is pi by 2. Half into 2 is minus 1. So r square into pi by 2 minus 1, option A becomes the answer. Spotting the 90 degrees is the challenge here. Once that happens, it's an easy question. So about 2 minutes to solve. In the given figure, O is the center of the circle of a circle. Angle AOD is 140, CAB 50. We have to find EDB. So let us join DB first. This is the angle to be found. Again, CDBA is a cyclic quadrilateral. Therefore, this angle plus this angle will be 180. CDE is a straight line, so this angle plus this angle will be 180. And therefore, angle BDE is equal to angle BAC. Exterior angle of a quadrilateral is equal to the opposite angle. BAC is 50, so EDB will also be 50. And that becomes our answer. I think this was one of the easy questions, not more than a minute to solve. So if you look at the overall about moderate level and 22 minutes to solve for 6 to 7 questions, my 6 to 7 questions would be 1, 2, 4, 5, 7, 9, 10. Which are these? Would be attempting this because Pythagoras theorem. This is also basic question. Opposite angles 180 and then 90-degree angle. This question again might not happen sometimes. So not counting is as a sure shot question. These questions are simple. We're just looking at similar triangles. Also, we would have done these kind of questions earlier. So both 4 and 5 I'm counting as attempt questions. Touch externally, common tangent. Drawing the diagram here might be a little difficult, so not counting this question exactly. 7th would have been attempted. It's just a matter of spotting that the circle has moved or drawing a straight line. Maximum minimum, I do not count these questions as sure shot questions because there is a case where we might miss a case and therefore get the wrong answer. This question again would be attempted because standard format of questions. This was a very simple question, so definitely attempting. So 1, 2, 4, 7, 9, 10 will give me my 6 to 7 net questions correct.